So on the quiz, first and foremost, you must read the problem. The number of things where I was like, you didn't even read the problem or didn't read it carefully. So let's look at the first one. So this is the one about the Rose Parade. The one float designer estimated 10% of the roses will not open in time. 20% will have insects and be unusable. 60 will be in perfect condition, and the rest will bloom too early and start to discolor. Conduct a simulation to estimate how many bundles of roses the designer needs to order so that she will have 15 bundles in perfect condition. The goal is to have 15 bundles. So we want to estimate how many bundles she needs to order so that she'll have 15 bundles. All right, then part A. This is the part where if I'd had hair, I would have been pulling it out. Describe how you will use a random number table. It says there in big letters, random number table. The number of people said, use a random number generator. I'm like, really? We're using a random number table to conduct the simulation. All right, I know that you can't see the screen, but I'm going to write anyway. So, what percent will be in perfect condition? 60%. All right. So, when we're looking at a random number table, you can do 2 digits if you want, but it's a lot simpler when all these things end in 0 to just use the first digit. So what I'm going to do is I'm going to let any number 1 through 6 be a bundle in perfect condition. You got to have it be 60%. I had people who were choosing number sequences where I'm like, that's not 60%. And any other number represent an unusable bundle. So you don't have to talk about all of them. You just need to know, okay, which ones are in perfect condition? What we will do, man, I'm having trouble. I think it's the electricity. What we will do is check each digit in the table, and you can put whatever you want for, checking off ones that are in perfect condition. Or you could, X out the ones that aren't in perfect condition.
So with the zeros, what do we?
Well, I said 1 through 6 are bundles in perfect condition, and anything else is not. If you want to start with 0, you can, but you would have to do 0 through 5. And you can do that. Until we have found 15 such bundles. then count the total number of bundles in each trial. So, if I use this on trial number 1 through 6, so in that first group, how many of them are in perfect condition? So 3, 5, 4, and 2, right? Yes?
Yes.
And then the next group, just 4 and 5. So far that's 4 and then 2. And the next one's 6, 4, and 4. So that's 3. So we're up to 9 so far.
And then 4, 2, 6.
4, 2, 6. That's another 3. That gets me up to 12. 13, 14, 15. So it took me 5, 10, 15, 20, 25 bundles to get 15 good ones. We didn't want the percentage of good bundles, which is one of the things that I saw. We want to know how many bundles did we have to pick before we got 15 good ones. Okay? All right, then on the next one, let's see, 4, 2, and 2, all 3 of those are good. The next one's 6, 5, 3, all those are good. The next one, 1, 6, 4, and 5, so all 4 of those are good, so that's 10. The next one, 3 and 3, so that's 12. 2 makes 13. 3 makes 14. 3 makes 15.
Yes.
So that's 5, 10, 15, 23. It took 23 bundles. You get the idea? I won't do trial 3 and trial 4. If you do it this way, then what you can do is go through, and it turns out that you need an average of 26 bundles to order in order to have 15 that are good. If on this you came out with a decimal, which is certainly possible, what should you report? You should report that, but then how many do they need to order? Because you're not allowed to order parts of a bundle. Yeah, the next bigger number. Since the average, let's say the average turned out to be 24.25. It's 4, so it's got to be 255 or 0.75. Well, then you need to add on one additional bundle in order to be assured of having 15, or more certain that you're going to have 15. Okay? Questions? All right, let's look at the ones on the back then. So at a local high school, and the people glossed over this, 3 students are randomly selected. We're gonna select 3. Right? We're not gonna select some great big number and see how many it takes until you get 3 girls. We're gonna select 3 every single time. So the class is composed of 15 girls and 12 boys. We would like to know the likelihood of having an all-girl panel. Design a simulation estimating this percentage. Describe the component, a trial, and the response variable for your simulation fully. I got a lot of I didn't even talk about any of those things. So, the component. The component is just selecting one, right? It's always just, how am I going to select somebody? So here we could use a random number generator. To get 3 integers, and people did all kinds of crazy stuff on this. How many total are there?
27.
27. To get 3 integers from 1 to 27. Let 1 to 15 represent a girl. And then 16 to 27 represent a boy. That's a component. Okay, what is the trial? And you could, for your component, you could just talk about individual ones if you wanted to. Just talk about, I'm going to generate a random number. I'm going to decide whether it's a boy or a girl. I think it's easier to include this, and I'm also going to add with no repeats. If you do your component without that, so that you just go, this is how I pick somebody and this is how I know whether it's a boy or a girl, then you have to say, if I get any repeats during the trial, I will throw that number out and generate another random number. Okay, because you can't pick the same person twice. So the trial is, we're going to look at the results of the component, and see if they are all girls or not. And then we're going to repeat this many times. Your response variable well, what are you counting? You're counting whether it's all girls or not. So the response variable is our result all girls or not? And we'll find the percentage that are all girls. That makes sense? So your component, how you pick one, the trial, you go through a complete series, right? We pick 3, we look at whether or not it's all girls, we're going to repeat that, and then the response variable is, well, what are we going to write down for each trial? The only thing we're writing down is whether it's all girls or not. at the end of the trial. All right, the next one is slightly different. And I think what has made this hard for some of you is that you were expecting them to all be the same. They're all a little bit different from one another. So here, person with type O positive blood can only receive blood from other type O donors. About 44% of the US population has type O blood. For our next blood drive here at school, we would like to estimate the number of donors we would need in order to get 3 donors with type O blood. Design a simulation to estimate this number. Describe the component, the trial response variable for your simulation fully. All right, so the component. So we're going to generate a random integer. And since it gave it in percentage, the easiest thing to do is do from 1 to 100. And let 1 to 44 represent a donor with type O blood. And any other number some other blood type. The trial. Repeat the trial. Actually, repeat the component until what? Yeah, until there are 3 type O donors. And then what do we want out of that? What is it that we're going to record? I'm sorry, you have to be a little louder for me to hear you.
The number of donors we need to get 3 donors.
Yeah, record the number of donors. We tested total. What is your response variable? That's the number of donors needed to get to 3 type O donors. Okay, that's very much like the one on the front, right? We wanted to see, well, how many bundles do we need to order before we're going to have 15 that are perfect? Does that make better sense now? Okie dokie. So yeah, let's slow down, read a little more carefully, think about those things, and then at the end, remember it's just a quiz. Okay, now if you make the same mistake on the tests, I'm coming to your house and complaining. Okay. But it's a quiz. It's not the end of the world. For some of you, And I really don't know who this applies to. And I don't know how much it applies because I don't really read over your homework. But I get the impression that some of you are either just copying the answers or not really, or not checking the answers, which is, the flip side that's equally bad, or something, because these questions were in chapter 10. So I would have thought, that there are some things that are complicated, but it would have been better. All right.